In our Open HPI course, Confidential Communication in the Internet, we want to introduce now the cryptography. Cryptography as a science which provides tools to guarantee the confidentiality of information. How this is done? You know this already. The cryptography is the science of encoding and decoding information. And what is the basic idea of encryption, of encoding information? Such an encryption makes information incomprehensible for any unauthorized outsider. So the meaningful, for example, text is converted into a very randomly looking sequence of signs and others, so one can no more understand the content and the meaning of this document. Only insiders who know how to reverse this encrypted document into the original document, they can get the information. By the way, it's reversing from the encrypted to the plain text document. This is the decryption. So encryption and decryption are carried out using cryptographic methods, and there is a variety of such cryptographic methods, but there are so many information which are sent over the internet that we do not have enough cryptographic methods so that we can change from each transmission to another transmission by one cryptographic method to another. And for that reason, the single cryptographic methods can be parameterized, can be controlled by a parameter, by a certain piece of additional information by means of the so-called keys. So we have our document in plain text, so one can read it and can understand it. And then there is applied an encryption method to encrypt this and transform this in a ciphertext. And this method is controlled by a key, by a secure key. And so the same encryption method can be used by many people for many documents. If we look to an example in the internet world, the DES, the DES encryption algorithm is very famous. So it starts with a message. For example, this is a confidential message. Then a key, that's a sequence of certain lectures, and the application of this key, secure key, to the DES encryption algorithms convert this text, this is a confidential message, in the following ciphertext. Ciphertext, that's the encrypted text. And here you see that this is a completely stupid looking sequence of letters and other signs and numbers and others. When we discuss such cryptographic procedures, then we have to know the Kerckhoffs principle. So Auguste Kerckhoff, it was a scientist, a cryptographic scientist from the 19th century, and he claimed that the security of such a cryptographic process should only be based on the secrecy of the key and not on the secrecy of the cryptographic process. And what's the idea behind this very important principle? The principle says the cryptographic process, the cryptographic method itself, they should be open. Everyone can know this method, so also these analytics, the cyber analytics people can investigate this procedure and can check whether there are some weakness or not. The application later on and the secrecy of the cyber text only depends from the secrecy of the key. When we look to the cryptographic methods, then we can see two groups. The one is the group of so-called symmetric encryption methods. And symmetric is the reason to call these methods symmetric methods is that they use the same key for encryption and for decryption. So the person which encrypts a key and the person that decrypts the message, they both need to know the key. Because both the encryption is done with the key and an encryption method, and the decryption is done with this method and the same key. So it is very, very important so that this algorithms and these methods can be applied in a secure way, that only sender and receiver know this key. Because everyone else who knows the key or gets access to the key can also decrypt the text, the ciphertext, and can see the content. There are a number of known and cryptographic methods. DES, I already mentioned, this is the data encryption standard. IDEA, the International Data Encryption Algorithm, is another important symmetric encryption method used in the internet. And the successor of DES is IES, the Advanced Encryption Standard, which DES is no more considered to be secure. So today one has to use the Advanced Encryption Standard. With the symmetric encryption methods, there is one fundamental problem: how to securely exchange the encryption key. If you use this in the criminal novels of the last century, then the both spions, they met in a bookstore and they exchanged the key, and then both go back to their flat or to their countries, and then afterwards they could send encrypted data, encrypted messages by means of the exchange key. But how to exchange a key when we are want to communicate over the internet? We cannot send the key to our partner because everyone else also can get the key, and then this unauthorized person that also got the key is also able to decrypt. So this is a very, very big and central question when using such symmetric encryption methods. Because both coming from the plain text to the secret text to the ciphertext, one needs the same key as one needs to decrypt the ciphertext into the plain text. We have a third group of cryptographic methods. We already mentioned the symmetric. Later on we will look to the asymmetric methods. Before, I want to mention the third group, and these are the hash procedures. So in computer science, hash functions are very popular, and they are also applied in the field of information security. And in information security, the idea of the usage of such hash functions is to generate fingerprints from documents. Fingerprints that characterize that document as precise as possible. The idea is, if we want, for example, to communicate a video with our latest research results, it's a huge amount of information. And to encrypt this huge amount costs very much resources. So the idea is to produce from the huge document a small fingerprint and then only encrypt the fingerprint. With this, we cannot guarantee the confidentiality when we send the videos, but we can guarantee the integrity. We will discuss this later when we discuss digital signatures. So the objectives to be able to use hash functions with that purposes is that the compression of a document of any length to a fixed length, for example 160-bit string, that it is done in a way that from the 160-bit string, it's almost no more possible to compute the original document. Practically, should it be impossible? So what we need in information security are so-called one-way hash functions. In the one way, from the document to the hash, it's very easy to compute. But in the other way, from the hash back to the document, this is almost impossible. Practically, it's impossible in the sense that it needs so much time whenever that this time is centuries, for example. The second objective of such cryptographic hash functions is they should be very difficult. It should be very difficult for a cryptographic hash function. It should be very difficult to find a second document with exactly the same hash value like our original document. We call this collision resistance. And we will later understand why this is a very important request for using such hash functions. The hash functions that are currently regarded as secure is RIPE-MD, is SHA-256. Here is seen as an example. If we use this SHA hash function for the text ABCD and for the text ABCDE, then you see very different hash values. Also, this original clear text are relatively similar. Of course, in this example, I do not use a large document. I showed this effect at hand of a very small example. Then we have SHA-512. This number gives the length of the hash value that's produced. And then there is a number of hash methods that are still in use, but can no more considered safe today. This is MD4, MD5. This is RIPE-MD 128. You see it's a shorter hash length than this. And the shorter, the more unsecure are such systems. And also the original SHA, which was used as a standardized cryptographic hash function by the NSA in 1992, is today no more considered secure. So we have the one group of symmetric encryption methods. We have the group of cryptographic hash functions. And the third group of such methods and procedures are the cryptographic asymmetric cryptographic methods. And here the characteristic property is that two different keys are used, one for the encryption and the other for the decryption. And we will see with this method, it's more easy and better applicable to the internet, because the exchange of the secret key that both times are needed is no more necessary, because we have two different keys. So every user gets a so-called secret key. It is called private key. It is called private key. And we have the public key. Public key is open. So for example, we can also look other procedures. We have a plain text, and with the public key of the receiver, this plain text is encrypted. Then it's sent to the receiver, and the receiver can use his or her private key to reproduce the plain text. What is important? That this principle is working. It should be impossible that the public key is created out of the private key. That the private key is created out of the public key. So the public key is published. The public key everyone can use. Everyone in our encryption participant of our encryption method. Everyone should know and can know it. But the private key must remain absolutely secure. If the private key, if my private key comes into the hand of anyone else, the system is no more secure, because this person then also can decrypt messages which were sent to me. And this was what I start to mention. To hold this private key absolutely privately, it should be not possible that it's to compute this out of the corresponding public key. Let's have a closer look to an example. And the first example when we discuss such asymmetric encryption method is the encryption example. And the encryption, I already mentioned this discussing the illustration, is that the public key of the recipient is used for the encryption. Then the message is sent to the recipient, and then the recipient can use its private key for the decryption. And because of this, because this private key is only known and is only available to the receiver, only the receiver is possible to decrypt the message. No one else. Even the sender can not decrypt the message. And for this asymmetric encryption methods, there is also a second usability way to use it. This is a digital signature approach. Here, the following is done. The document is encrypted with the private key of the signee. So I crypt, for example, a contract. And then everyone who wants to check whether this information really comes from me can uses my public key, and with my public key he or she can decrypt the document. And this is considered a proof. If it's possible to successfully decrypt the document, then it's a proof that this message really comes from the signee, because only he or she were able to encrypt this in such a way with a private key that it could be decrypted with the corresponding public key. How to attack encryptions? Encryption method, whether it's symmetric or whether it's asymmetric. With a hash function, we have to discuss other attack methods. In any case, particularly for the symmetric encryption method, the brute force attack is a possible attack that not can be prevented. And the idea behind is simply try out all theoretical possible keys. So if we know the key is of length 100, and it consists of symbols from that alphabet and this special signs, then one can systematically start with probing all the letters of the alphabet, then all the words of length 2 with 2 letters of the alphabet, and checking length 3. At the end, it is a very, very costly and very time process. At the end, the attacker will find the real key. So we cannot prevent such brute force attack. So the only protection against such brute force attack is that the number of possible keys must be so large that a systematic testing needs too long. It's practically impossible. For example, cost with the best computers thousands of years. To round up, in later clips of the course, we will discuss the symmetric and asymmetric encryption methods in more detail. But here, to round up the introduction, we have to see what are the important differences between the symmetric and the asymmetric encryption methods. You remember the symmetrical procedure, which also called secret key procedures, because the key needs to be secret. They typically are based on very simple mathematical functions to only change neighbored bits. So typically the keys are bit strings. So to change, to perform a logical AND or XOR others. The asymmetric procedures, which are also known as public key procedures, they are based on very complex mathematical facts. So public key procedures require much more computing resources to evaluate an encryption or to evaluate to perform a decryption than the secret key procedures, because the secret key procedures are very simple, do simple operations, and because the public key procedures are based on complex mathematical functions, they are more susceptible to implementation errors. In case of the secret key, symmetric procedures, plain text, cybertext are considered as bit strings. When we consider asymmetric public key procedures, then we interpret the key, the plain text, the cybertext as large numbers. And this difference makes it clear. Here, when we consider bit strings, we have the simple bit operations. Here, when we use complex mathematical functions, we interpret the key and plain text and text and cybertext as large numbers. So this was a first introduction into the cryptographic methods, the symmetric, the asymmetric methods, and into hash function. And in the following videos, we will have closer look and also consider some examples.